Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 1800 maximum ascending subarray sum. It's an array question and it's an easy one, so good for those who are getting starting with their preparation. And this question has been asked in TCS. Let's have a look on the problem statement. We are given an array of positive integer nums, and what we have to return, maximum possible sum of any ascending subarray. This is our problem statement. What is subarray? They have also given the definition of subarray. Subarray is just like a piece from the array. If this is the array, if I just cut this piece, then this piece will be called subarray. What else? They are also saying that the subarray will be called ascending if for every I this condition is getting fulfilled. The next item is greater than the previous one. Nums I plus 1 is greater than the previous one, not even equal. So this is the definition of ascending subarray. Find the sum of that subarray. Okay. So if I just have a look on this example, what should be the answer of that example? Firstly, just check all the increasing or ascending subarray. If I just have a look, this is one ascending subarray. 10, 20, 50. 20 is greater than 10, 30 is greater than 20. So if I just take a sum, it is 60. And this subarray is also ascending 5, 10, 50. 60 plus 5, 65. So there were ascending array 1, ascending array 2, and the maximum sum is 65. So we are going to return 65 from our function. So this is our problem statement. Now let's see how we can do that. One thing is that our subarray will be something from I to j, and I value will go from 0 to n minus 1, right? So we can start our array from every possible index, and we can keep moving in the right direction if we are getting greater element. If I plus one item is greater than I, then we will just keep on moving, and if we are moving, we'll just capture our temporary sum of that subarray, and in the end I will just capture the maximum temp in the global variable. If we apply our brute force, we are going to check every subarray starting from index I. Index I, the array will be something like this. From index 2, array will be this. From index 3, only one element in the array. From index 4, 3 item in the array. From index 5, 2 item. From index 6, 1 item. It means starting from every index, we are just iterating till the right direction where we are finding the greater element. In this case, from every I, we are checking all the possibilities of j, so it will go n square time in the worst case. But as, let's say, we started from 10 and we are going in this direction, right? At 20, we are also comparing 20 and 30, which are already checked, right? So we can optimize this approach further. In our optimized approach, what we are going to do is we will start from this index. We will keep our current sum, and you can say we will just capture our maximum. Maximum is minus infinity for now. Current sum is 10. And when we are coming here, current sum is 20 plus 10, 30. And why we are considering that element? Because this element is greater than the I minus 1 element. When I'm coming here, 30. 30 is greater than the I minus 1 item. So 30 is also included, and the current sum will become 30 plus 30, which is 60. And now when I come here at this position, the current item is not greater than the previous one. So we just have to break the scenario what we were following, and we'll just capture our maximum sum. Maximum sum is 60, and the current sum will be updated to the current value. Okay, because we are doing a fresh starting. Next item, this is greater than the previous one, so 5 plus 10, and this is also greater than the previous one, plus 50. And now we are going out of bound, so we'll break the condition, and now the current sum is 65, and the updated sum will become 65 now, because 65 is greater than 60. So in the end, the answer will be 65. And you can see we have done only one iteration. If there is only one iteration, what is the time complexity? Time complexity is order of n. What about the space complexity? we are not taking any extra space. So this is our optimized approach. Let's try to write a pseudo code for this approach. First of all, what I did is, for every I, let's say I'm starting from I equal to 1 and I going to n minus 1. Why? Because in my current sum, one item is definitely an ascending array. Okay, so that's why the temp is nums of 0, and you can just take another maximum variable minus infinity. Temp is minus 0. Instead of minus infinity, maximum you can capture as the equal to the temp, which is nums of 0, because this is one possible answer, right? So from I to I minus 1, what I'm going to do now, I will run a while loop. While ith item is greater than I minus 1th item. If that is the case, temp plus equal to I and I plus plus. So this is I will do. But you also need to make sure that you are checking whether the I value is valid or not. That is very important. I less than n, and this is the condition. So now when this while loop will break, it means our ascending array is over. Now we just have to capture our maximum value. So maximum is equal to math.maximum comma temp. Capture our maximum value, and my next array is going to start from this I. It means the temp can be updated to nums of I. Temp is equal to nums of I, this position. Temp is nums of I, and in the next position I will just keep on doing the same logic. So this much we have to do. But there is one issue in this problem. Like here at this position you are just assigning nums of I. What if we are coming out of while loop because of this condition, I less than n? So in this case you need to add one more condition as well, that when you are assigning temporary variable to I, you also need to check if I is less than n. So these kind of special cases, like whether I is not going out of bound here in the while loop, these are very important. Sometimes people forget applying these logic when they are doing the coding in the interview. Okay, now just quickly run this code. First of all, let's capture the length nums dot length, and my temporary variable will be initialized to 0. And what about the max variable? Max variable is also the same, because this is one candidate. First item is itself a subarray which is ascending. Now for loop, I is initialized with 1, I less than n, I plus plus. Now while I have a valid I and nums of I is greater than nums of I minus 1. If that is the case, temp will be appended with the current num value and I will be incremented. And here you just have to update your max, math.max, current max, and the temp value. If we are coming out of this while loop by breaking this condition, nums I greater than nums I minus 1, it means we are at this position at 5. So in this case I also need to update my temp to nums of I, so that when in the next iteration it will have a index pointing to this 10, and this 10 will be compared to the previous one, which is 5. But if condition is breaking at this position, I is less than n, in this case we also need to check add a check here. If I is less than n, it means I should be valid. At every step I should be valid, otherwise we are going to pick a value of I which is equal to n, which will give us compilation or runtime error. Okay, this much we have to do, and in the end just return the maximum value we have captured. Let's run our sample test cases. Sample test cases are passed. I'm submitting the problem. It was submitted successfully and 100% faster. I hope you have understood the approach. Thank you guys. Bye bye.